Okay, welcome back. Now we're at part 2. We're going to go over the primitive types. So let's get into it. Okay, let's get back into the curriculum. 2.1.3, primitive types. A primitive data type is a basic building block. Using primitive data types can build more complex data structures called object data types. Remember that term. Java uses its own set of primitive data types. The table below shows the most common types that beginners are likely to encounter. A more complete list can be found at the Oracle website. Click on it, go here, do some reading. There's a lot of information here. This will help you understand. Trust me. But bookmark that, create your file or folder on your desktop or in your browser for Oracle documentation so you can know where to find it. All right, let's get back to the curriculum. Now, Java primitive data types. Here we go. We got data types here. We got int. Here's an example. It's a number 42. Represent positive and negative whole numbers. Float. It got the point in there, so 3.14, and it goes all the way up to this point right here, and 2.0. Represents positive and negative decimal numbers with up to 7 digits. Now, the double, on the other hand, it goes a little bit further, and it says represents positive and negative digit numbers with 15 to 16 digits. Character, 1 character, a single Unicode, know that term, Unicode character enclosed in a single quote. Remember, it only takes single quotes. You will get an error if you try to use double quotes. Then, of course, Booleans, which are true and false. Booleans in Java are not capitalized. Remember that if you're new to Java. If you're coming from JavaScript, you already should understand this. Now, warning here. We will see in a later section the float data type sacrifices some accuracy for speed of calculation. Thus, evaluating 1.11111 plus 3 results in an answer of 4.1111097 instead of 4.1111. Anytime you need to perform calculation with decimal values, consider using double types instead of floats. What's the difference here? It's the use case for this is a banking application, something where you got to be precise right down to the very penny. You want to use a double, not a float. But if you understand the data type that you're using, the information that you put in there, and you know for a fact that you're not going to have to go that high, you can use a float. And like I said, even on the end, if you're using the end, you know that the number is going to be a small whole number. You just got to understand when and where to use it. So that's why it's important to understand what each one does. Okay, and we'll go over that more. So here we go, 2.1.4, 9 primitive data types. Primitive data types are immutable and can be combined to build larger data structures. One example is forming the string launch code for multiple characters, LAU, etc. Strings in a non-primitive data type, also called an object type. Object type, that's what that capital string we know as an object, as we saw in the string table above. Object types have methods which can call using dot notation. Primitive data types do not have methods. Again, if you're new to Java, this may not make sense, or new to any programming language. But what this means is, and people that's coming from JavaScript understands this, primitive data types are immutable, meaning they can't change. And also because they do not have methods or properties. Objects have methods and properties. And this is when you see that dot, we call it dot notation because that method or property wants to have access to what's ever in that object. We'll give you examples as we go further. If you're coming from JavaScript, you already understand this. Primitive data types in Java begins with a lowercase letter, while objects data types in Java begin with a capital letter. Letters in this chapter will explore the array and class objects. Now we're here to autoboxing. 2.1.5. Autoboxing. There may be situations when we call a method that accepts an object as an argument, but we pass it a primitive type instead, or vice versa. In these cases, we need to convert the primitive type to an object, or convert an object type into a primitive. In older versions of Java, it was the programmer's responsibility to convert back and forth between primitive types and object types whenever necessary. Converting from a primitive type to an object type was called boxing, and the reverse process object to primitive was called unboxing. Here's an example. We have this int, some integer, we assign it 5. Integer, some integer. Now we have an object called integer. This is a primitive. This is an object. Integer dot value of some integer. Class name, method name, and some integer. This is just syntax right here, because the class name is whatever the class name is, and then whatever the method name, and then we're going to pass in this as an object, as a value. Line 1 declares and initializes the variable some integer. Line 2 converts the primitive int to an integer object. It's just been converted. Remember, we're using conversion here. Line 3 calls method name and passes integer object as the argument. If method name expects an object type and we try sending it and instead, we would generate an error. Unboxing. Let's assume that a method returns a random number of integer type, and we want to combine it with a value of integer type or int type. The int, our number 5, integer random number, class name random generator, int random int, and then we have the int inside of these parentheses random number. Int sum assign our number plus random number. So now we're assigning these both to the sum. The breakdown here, line 1. Line 2 declares and initializes a random number as an integer type. So this is going to be the object, right? Line 3 converts random number to an int. Line 3, random number gets converted to an int. This is called casting, and we'll learn about that later on. And stores the value in the random int variable. So now it's being converted, and now it's stored in a new variable, which has the int initialization. Converted between data types in order to pass values between methods quickly become tedious and error prone. In the newer version of Java, the compiler is smart enough to know when to convert back and forth, and this is called autoboxing. That's why it's called autoboxing, because it does it for us automatically. Cool, you didn't write that, so that's another gift, all right? For us, the consequence of autoboxing is that in many situations, we can use primitive and object types interchangeably when calling methods or returning data from those methods. Here's a tip. It's the best practice to use primitives whenever possible. The primary exception to this occurs when storing values in collections, which we'll learn about in future lessons. Each of the primitive data types has a corresponding object type. Here's the examples right here. You're familiar with those. Now here's some references. Go ahead and let's go to these references. Go ahead and read this. This is important. This is something you want to have in your tool chest. This is in your toolbox. Go back and look at this documentation, because this documentation here is way more extensive than what we're teaching you. Don't sleep on this information. use this information. It's just going to help you understand something. And what that means, you begin to see something that you didn't see at first. You'll start having those aha moments. So make sure you use those references that we're giving you. Now, also check your understanding. And now we have ended the first section of chapter 2. Now, go back and go over this again if you're struggling to understand. The more you practice, the more you'll improve. Like I said, don't sleep on this. This is information that's sometimes can be kind of complicated to understand at first because we're hitting you with a lot at one time. But it's up to you to put the effort in and to do your due diligence. Okay? So I'll see you in the next section.